Hello and welcome to my channel. I am the Mad Computer Scientist. On this channel, I discuss math, computer science, and technology topics that are of interest to me. But before we begin today's video, which is the long-awaited topic of bubble sort, I would like you all to do me a couple of favors. Please remember to like the video, remember to comment on it, and be sure to ring that notification bell and make sure you hit the all button so you will always receive the latest notifications of videos that I post. Now, I do apologize for the delays in getting to this one, but now we're finally going to discuss bubble sort. But before we do that, we're going to discuss something else first that is important to many different computer science algorithms, and that is the naive algorithm. And no, this does not mean an algorithm that does not yet have any worldly experience. We're talking about something slightly different, which we will get into in the next slide. The most important thing to remember about these algorithms is that it's not a specific algorithm that is being referred to. It is typically just the first algorithm someone comes up with when trying to solve a particular problem. And this is true in both math and computer science. It is often the least efficient way of doing something. This can be overcome by optimizing your code to make it more efficient, or seeing if there are other algorithms available that can speed up your code execution. All right, for sorting, the first naive algorithm most people come up with has a runtime of n factorial, but there are more efficient ways of doing that, as we're going to get into. One of the earliest sorting algorithms most people learn is bubble sort, which has a runtime of n times the quantity of n plus 1 all over 2, which, if you've studied discrete math, you probably recognize that formula. Before going over the code for the algorithm, which we will do in the next slide, I thought it might be helpful to go over this quote I found on the internet, and the source is at the bottom of the slide for those of you who are interested. Just pause it and type in the link. A naive sort, also known as brute force or generate and test, is a sorting algorithm that generates all possible permutations of a list and then tests each permutation until one is found that is correctly sorted. The number of permutations of a list is n factorial, where n is the length of the list. For a relatively small number of items, such as 24, there are 6.20448 times 10 to the 23rd permutations. Due to the resource cost and time needed to generate and test the permutation of the list, programmers seldom use the naive sort algorithm. Now that we have previewed our coming attractions, it is time to go on to the main attraction. I hope you all have your popcorn ready, because you have been waiting for this video for a long time, because I promised it at least 6 months ago. Before we begin coding any algorithm, we have to understand the basics of how it works. You can write a flowchart to help it if you use flowcharts. I personally prefer pseudocode. But for this, we're just going to go over the basics, and then we're going to show a visualization that will help some people understand. It starts off by comparing the first two numbers in an array or list. If b is greater than a, b is swapped with a. Then it'll go through the list for each number and repeat the process. It uses two loops. The outer loop has the number of iterations that are equal to the length of the array minus 1, and we can start that array at I, where I equals 0, and we just use I because it's tradition. Now, for the inner loop, because it's law, programmers are going to use j as its initial value. It starts at j minus, sorry, that's I minus j minus the length of the array minus 1. And if you're wondering about the minus 1, it's so we can avoid something very common in programming called an off by 1 error, which usually occurs because array counts start at 0. And this particular loop will run the entire length of the array. And the process continues until both loops complete. If you would rather not go through an oral presentation, perhaps because you're a more visual learner, here is a visualization of how the loop works, which is a fairly accurate depiction. If you would choose to pause this video, go ahead and screenshot this so you have it to refer back to. If you have followed this channel for a while, you know how I like to end my videos. We're going to do what I suggest we do at the end of my videos right now. I have put the PHP code on the screen for you. If it's a little small, feel free to look it up, or if you want a little coding exercise, just convert it to your favorite language. Now, I know a lot of people have said PHP is dead, that JavaScript frameworks negate the need for PHP, although I personally feel Python frameworks negate the need for JavaScript frameworks. But the truth is, PHP is still better for back-end server-side web development than JavaScript, and is generally easier to use. Now, I do not necessarily feel that its syntax, which is based on Perl, was the wisest choice, and perhaps someone should come up with a more efficient server-side language rather than using JavaScript. Now, since we've discussed bubble sort and how to program it, let's discuss what the advantages and disadvantages of this algorithm are. The pros are that it is easy to implement. In fact, high school computer science students are often given this as a programming exercise. It's faster than the typical naive sort by a considerable margin, and it works well for small programs. The disadvantages are that it's slow compared to other more advanced algorithms, and the slowness can make it expensive when it's run on large data sets, such as the one Amazon uses for its customers. It's also not ideal for applications with more than a few dozen users. And when writing code, especially commercial code, you'll want to keep in mind the audience of the program you're writing it for, rather than just doing what is easier. Now you may be wondering, since bubble sort has some limitations, which all algorithms do by the way, are there other sorting algorithms that work better with larger data sets? And indeed there are. One of the most interesting ones I've seen is in JavaScript that uses the set timeout over an array, but I don't think that's very efficient. The actual algorithms will be merge sort, which has a worst case runtime complexity of n squared, and a best case runtime complexity of n log n, which works well for most things. Now there is another algorithm that's fairly quick, where it's always n log n, and that is heap sort. And heap is a data structure that I'll probably discuss at some point later. But the most efficient sorting algorithm, at least of the ones included here, is quicksort, which has a worst and best case runtime complexity of log n. And keep in mind, in computer science, unless otherwise specified, every time we say log, we always mean log base 2. And now you have made it to the end of the video, our feature presentation. Please remember to like, comment, and subscribe. Be sure to ring that notification bell if you do subscribe. When you use the comment section, if you want to leave ideas for future videos, please do so. And join us next time as we explore basic algebraic solving problem techniques. I hope I will get to this far faster than I got to this one, but again, I'll be rather busy coming up soon. Remember everyone, go out and write some code.